Hello, I'm Taylor, and in today's video, we're going to be exploring the concept of heat. Now, heat is a very unique concept for chemists because it relates to energy. And energy is really important because energy is present in every single type of reaction that occurs. In every reaction, energy is either released or absorbed. And while we cannot taste, see, smell, or hear energy moving through reactions, we can feel it. And we feel it as heat, particularly when we touch something and feel it being hot or cold. Now, as I mentioned, there are two predominant types of reactions that occur. If energy is released, then heat is given off, and we call those types of reactions exothermic. Exothermic are reactions that when they occur, heat is released and energy is released out into the world. Now, the second type of reaction occurs when energy is actually absorbed, which means that heat is sucked into the reaction going on, which means it's cooler to the touch. And we call those types of reactions endothermic reactions. Endothermic reactions require energy or have to absorb energy in order to happen. The classification of endothermic and exothermic reactions are really important for our daily lives. For instance, in order for a refrigerator and a freezer to keep your food cold and safe, it has to absorb air, or has to absorb the heat from the air within the refrigerator, which involves an endothermic reaction. And for my truck to move forward, my engine has to engage in exothermic reactions. Essentially, little explosions go on in an engine, which is why we call them combustion engines, which release energy, and that released energy is sent to my tires, which move the truck forward. So cool. Now, in today's experiment, we're going to explore how heat moves through reactions and whether they're exothermic or endothermic by taking temperatures. Now, it's important to understand that for chemists, temperature and heat are two different things. When we walk outside on a hot 95 degree Fahrenheit day, sweating so much, and we say, "Oh my gosh, it is so hot out here," we're referring to temperature. Yet, if we walk past a pan on our stovetop that's been cooking our dinner, and we touch it and we go, "Ow, that's really, really hot." That is, we're talking about heat. So what exactly is the difference? Temperature is a measurement on how hot or cold something is. And we usually represent this in America as degrees Fahrenheit, while most of the rest of the world uses the metric system degrees Celsius. Heat is a little different. Heat refers to the amount of energy that is transferred from one thing or substance out into the environment. So when we touch that hot pan, heat or energy is transferred from the hot pan into our finger, and we experience it as really hot. And because it's really hot, it's really painful. So for today's experiment, we're going to need a number of things. Ask a parent or guardian to help you gather the following. 1, 2 cups of water, separated into 1 cups each. 2, 1 cup of vinegar. 3, a half cup of hydrogen peroxide. 4, a half cup of Epsom salt. 5, a half cup of baking soda. 6, 1 packet of dry yeast. 7, 3 ice cubes. You'll want to get these later. Just have them ready in the freezer. 8, 1 piece of paper. 9, a pencil or pen. 10, a thermometer. 11, a stopwatch. I'm using this iPhone right here. 12, safety goggles. While nothing that we're working with is dangerous, it's just good practice to keep our eyes covered in the event of splashes. And 13, a calculator. All right, now that we have all the materials that we need, what we'll be doing is actually performing 4 separate experiments to see how each of them how the temperature changes in each of them to find out and to determine, are they an exothermic or an endothermic reaction? Now, the process or the steps will go as follows. First, you'll take your liquid and you'll take your thermometer and you'll measure its initial temperature. Then you'll record that temperature down, and we'll go over in a minute what we're going to be recording on. Then you're going to take your additive and add it in, and then let it sit for 2 minutes so you can give time for the reaction to occur. Then you're going to take your thermometer again and take the temperature of the liquid with the additive still in there and record that temperature down as well. And we'll call that temperature our final temperature. Then, using your calculator, you'll get the difference between the final temperature and the initial temperature. If that difference is negative, or a negative number, then we know that the reaction was endothermic because heat was absorbed, thus lowering the temperature of the liquid. If the liquid's temperature or the difference is positive, meaning that the final temperature was higher or hotter than the initial temperature, then we know that the reaction was exothermic because it gave off heat in the reaction, thus warming the liquid. So now that we have everything that we need for our experiments, and we have all the steps that we're going to be doing for each of the 4 experiments, we need to do one last thing that's going to help us. And that's to create a table so that we can record our data and keep track with what is actually going on. So this table will need to have 5 columns. The first column will be the liquid that's being used. The second column will be for the additive that is being put into that particular liquid. The third column will be the initial temperature reading that we get. The fourth column will be the final temperature reading that we get. And then the fifth column will be the difference between the final temperature and the initial temperature, which will ultimately help us determine if this reaction is endothermic and exothermic. I've drawn a sample table up for us today, and it looks like this. All right, our first experiment is with 1 cup of water as our liquid, and then with a half a cup of Epsom salt as our additive. Now, of course, our first step is to take our temperature with our thermometer, and my thermometer is set at Celsius because that's what chemists and a lot of scientists typically use. But you can do this experiment in Fahrenheit as well if that's the only thing your thermometer reads. So I'm going to take this and I'm going to get the initial temperature right here, which we've got an initial temperature of 21.5 degrees Celsius. So I'm going to write that down here. So water, Epsom salt, what was it? It was 21.5 degrees Celsius. Now we're going to take this half a cup of Epsom salt and pour it in. We're going to pour it in carefully. All right. Get all that salt in there. Okay. And now I'm going to take my timer, set it for 2 minutes, and then we're going to wait for 2 minutes. Now, while we're waiting, the main question I have for you is, what do you think is going to happen? Do you think this reaction will be exothermic or endothermic? All right, now we wait. And there goes our timer. All right, so now we're going to check our temperature. Let's see here what we get. Oh, check that out. The temperature is at, we're getting an initial reading, 15.7 degrees Celsius. That's quite a drop there, 15.7 degrees Celsius. And so now let me take my handy dandy calculator right here, and I'm going to do our final temperature of 15.7 degrees minus our initial temperature of 21.5 degrees, which gives us negative 5.8 degrees. Now, because our final temperature, our temperature difference between our final and initial temperature is negative, that means that this that mixing the reaction between Epsom salt and water is endothermic. And that means that the reaction absorbed energy, taking heat out of the water and thus cooling the water down. How cool is that? Now, our next experiment is between our 1 cup of vinegar and our half a cup of baking soda. So just like we did with the last one, we're going to take our temperature reading. And this one is reading at 20.8. Wipe that down. So our vinegar initially reads at 20.8 degrees Celsius. Now we're going to take our baking soda and we're going to put it in. Now this reaction will give some cool kind of visuals for us to kind of see. I'm going to also get my timer and set that. Whoops. Joys of phones. There we go. All right. Check this out. Oh, we got bubbles. All right. Well, we had a little bit of an explosion, a little bit of a mess. That's why we wear safety goggles, just in case something happens. So I'm going to get the rest of my baking soda in here. Okay. So now I'll set my timer and we'll wait 2 minutes before we take our temperature. All right. All right, there goes my timer. Let's check our temperature. Do you think this reaction is going to be exothermic or endothermic? Let's take our temp. All right, 15.8 degrees Celsius. Okay, there we go. So now we'll use our calculator and we'll take our final temperature of 15.8 degrees minus 20.8, which gives us a temperature of -5 degrees Celsius. So that means that it's endothermic. So what that means is that in order for this reaction to occur, it had to absorb heat and absorb energy for it to happen. And that's why the vinegar got colder after the reaction happened. All right, let's move on to our third experiment. This experiment is between our half a cup of hydrogen peroxide and a packet of dry yeast. So before we open up the dry yeast, we've got to take our initial temperature. Let me check that. And that is going to be still reading 20.9 degrees Celsius. Okay, now let's take our dry yeast. I'm going to open one of these packets. I'm going to have to do this a little unscientifically. Okay, there we go. Now we're going to pour this in here. Oh, check that out. It's bubbling up. We're going to set our timer for 2 minutes. All right, now we're going to wait 2 minutes and come back, and we're going to get our results.
Oh, not that one.
All right, our timer is up. Let's check. All right, we've got our thermometer. We're going to put it in here. Let's see what we're reading at. Oh, wow. We are at 33.0 degrees Celsius. All right, write that down. 33.0 degrees Celsius. So now we're going to take our calculator and we're going to do 33.0 minus 20.9. And that gives us a temperature difference of 12.1 degrees Celsius, a positive 12.1 degrees Celsius. So what does that mean? That means that this reaction is exothermic. It means that when the yeast and the hydrogen peroxide reacted together, they gave off or released heat. And as a matter of fact, it would be difficult to see on the video, but you could actually see steam rising up, and you can even touch the glass container, and it is warmer. And what's interesting is if we take our glass container with our hydrogen or with our vinegar and baking soda mix, this one's cold to the touch, while our baking soda, or excuse me, our hydrogen peroxide yeast mixture is warm to the touch, which goes back to the difference between an endothermic reaction and an exothermic reaction. Now it's time for our final experiment. This fourth experiment is with water and ice cubes. Now, you probably know what's going to happen, but we're going to go through the experiment anyways, because there's more going on than meets the eye. So we're going to start as usual by taking our initial temperature reading. So I need to actually wipe this off. All right. So we'll take our initial temperature reading, which is 21.9 degrees Celsius. All right. Okay. And now we're going to take our 3 ice cubes and put them into our water. I'm going to set the timer for 2 minutes, and we're going to wait. And as we wait, again, I want you to ask yourself, is this going to be an exothermic reaction where it gives off heat, or is it going to be an endothermic reaction where it absorbs heat? You might have a clue if you've ever put ice in your drink on a really hot summer day. But again, I want you to know something. There's more going on than meets the eye. All right, our time is up. We're going to check our temperature. So, as usual, we use our thermometer, and we're going to put it down here in our water. Now, ice water. Let's see what the difference in temperature is. Oh, wow. It looks like we've dropped down to 12.4 degrees Celsius. So I'm going to write that down here on our table. 12.4 degrees Celsius. Okay, so I'm going to take our calculator, and I'm going to find the temperature difference. So 12.4 degrees minus 21.9 degrees gives us a difference of negative 9.5 degrees Celsius. Wow. So what that means is that, and probably no surprise, our water got colder. But why exactly did it get colder? Well, what it means is that when you put ice in your drink, you are doing chemistry because an endothermic reaction is happening. Now, it's important to clarify that the type of reaction happening here in the ice water is a little bit different than the type of reaction happening here with the hydrogen peroxide yeast. The hydrogen peroxide yeast is a chemical reaction. There is a chemical change going on here. The reaction with ice and water is a physical reaction because there's no chemical difference between ice and water. They're both H2O. However, physical reactions also require energy. And so this reaction is endothermic because what happens is the ice absorbs the heat from the water, thus causing the ice to melt, but ultimately causing the water to get colder, which is why you put ice in your drink on that hot, balmy 95-degree day, because you want a cold drink of water. You want the ice to take the heat from the water so that when you drink it, it is nice and cool and quenching. Well, that's it for today. Thank you for joining me to learn about endothermic and exothermic reactions. They're a huge part of chemistry, and they're really important for us in our daily lives. I hope that you can take some time to notice some exothermic and endothermic reactions in your daily life today. Thank you. Bye-bye now.